Question 28, Part A. A long rectangular sheet of metal, 28 centimeters wide, is to be made into a gutter by turning up sides of equal height x centimeters perpendicular to the base. Part 1. Show that a formula for the cross-sectional area, A, of the gutter is A equals 28x minus 2x squared. The original width of the piece of sheet metal is 28 centimeters. Now x centimeters is turned up from each side to form the gutter. Now the shape of the cross section of this gutter, A, is a rectangle with height x centimeters and width given by 28 centimeters minus x, which is 28 minus 2x centimeters. So to find the area of rectangle A, which represents the cross-sectional area, is found by multiplying the width by the height. So the area of rectangle A is 28 minus 2x in brackets multiplied by x and expanding the brackets. So 28 times x minus 2x times x is equal to 28x minus 2x squared. Therefore, the formula for the cross-sectional area A is A equals 28x minus 2x squared as required. Part 2. Explain why the formula in Part 1 is only valid for values of x between 0 and 14. X represents the height of the gutter, which must be greater than 0 centimeters. Now when x equals 14, the cross-sectional area A is equal to 28 times 14 minus 2 times 14 squared, which equals 0. That is, the area of the cross-section is 0, which is invalid. Now any value of x greater than 14 centimeters, when substituted into this formula, will result in a negative cross-sectional area, which is also invalid. Therefore, the formula is only valid for values of x greater than 0 centimeters and less than 14 centimeters. Part 3. The graph of A against x for values of x between 0 and 14 is a parabola, as shown. What is the maximum value of A? The vertex of the parabola represents the maximum cross-sectional area, and it occurs at a value of x that is halfway between 0 and 14. And a value that is halfway between 0 and 14, which is the average of 0 and 14, is x equals 7. Now when x equals 7, the cross-sectional area is given by 28 times 7 minus 2 times 7 squared, and this is the formula from part 1, and that equals 98 square centimeters. Therefore, the maximum value of A is 98.